So before we discuss thoroughly about AC generators or alternators, let us first differentiate it from a DC generator. So this tabular comparison is credited to byju's.thelearningapp.com. So by definition, a DC generator is a mechanical device that converts mechanical energy to a DC electrical power, while an AC generator is a mechanical device that converts mechanical energy into AC electrical power. So with respect to the direction of current, so in a DC generator, the electrical current flows only in one direction, while in AC generator, the electrical current reverses direction periodically. So when considering the basic design, in a DC generator, the coil through which the current flows rotate in a fixed field. So the overall design is very simple, but its construction is complex due to commutators and slip rings. So in an AC generator, the coil through which the current flows is fixed while the magnet moves. So the construction is simple and costs are less. So with respect to commutators, DC generators have commutators to make the current flow in one direction only, while AC generator does not have commutators. DC generator produce a low voltage compared to an AC generator, which is constant in amplitude and time, meaning the output frequency is zero. So AC generator produces high voltage, which varies in amplitude and time. So the output frequency varies mostly from 50 Hz to 60 Hz. So when considering maintenance, DC generator require a frequent maintenance and are less reliable, while AC generator requires very little maintenance and are highly reliable. So with respect to distribution and transmission, the output of DC generator is difficult to distribute as transformers cannot be used. On the other hand, the output from AC generator is easy to distribute using a transformer. So lastly, DC generators are less efficient due to sparking and other losses such as the copper eddy current, the mechanical and the hysteresis losses, while AC generators are very efficient as the energy losses are less. So on board ships, the emergency generator, diesel generators 1 and 2, turbo and shaft generators are alternating current or AC generators. Hence, as future marine engineers, it is important to understand the fundamental working principles of an AC generator or alternators. So for this lecture, the discussions and illustrations are from Practical Marine Electrical Knowledge, 3rd edition of Dennis Hall. So in order to understand how this type of generator works, let us recall the principle of electromagnetic induction discussed in the previous lecture. So take note that we can induce voltage or EMF if we move a magnet in and out a coil. Okay? So also, the same result will be observed if instead of moving the magnet, we move the coil in and out. So the working principle of an AC generator is based on the former, while the latter for a DC generator. The figure here shows the basic construction of a DC generator. As what we can see here, the rotating component is the conductor, while the magnet is the stationary indicated by N and S. In contrary, in this figure, the rotating component or the rotor is the magnet. So this is a simplified diagram of an AC generator or an alternator. So the force that makes the rotating force is called the prime mover. On board ships, the main generator power ratings range from typically 250 kilowatt to 2 megawatts at 440 volts 60 Hz. AC driven by diesel steam turbine, gas turbine, or propulsion shaft-driven prime movers. So an alternating electromotive force, or EMF, which is ideally has a sinusoidal waveform, is induced into each stator phase winding. So the useful EMF level is called the root mean square, or RMS value. So the voltage that you can measure in multimeter is an RMS voltage, while the peak voltage can only be seen in an oscilloscope. So the RMS voltage can be computed as 0.707 multiplied to the peak voltage, meaning if the peak voltage generated by an alternator is 622 volts, the effective or useful voltage is only around 440 volts RMS. Also, almost all equipment such as rice cooker, refrigerators, flat screen TVs, and electrical motors are rated using RMS voltage. So the frequency F, measured in hertz, of the generated voltage depends on the rotational speed of the prime mover and the number of poles in a generator. So the relationship of frequency, rotational speed, and the number of pole pairs can be expressed in this formula. So where F is the frequency in hertz, N is the revolution per minute, or RPM, P is the number of pole pairs. So this table here summarizes the values of RPM and number of pole pairs for 60 Hz frequency. So normally, the alternators on board ships have 4 pole pairs. Hence, to produce a voltage at 60 Hz, the required RPM is around 900. So we can see these values and effect of increasing and decreasing the governor to change the frequency in the engine room simulator. Using this Kongsberg engine room simulator, we will do the following. Number 1, confirm that the rotational speed of the 4-pole diesel generator is around 900 RPM and generates voltage with 60 Hz frequency based on the table in the previous slide. And then number 2, we will confirm that the frequency and RPM of an AC generator has direct relationship, meaning increasing the RPM through the governor increases the frequency of the generated voltage. And at the same time, if we decrease the RPM, this should result to a decreased frequency. So, as what we can see here, the speed of our diesel generator 1 is around 900 RPM. So let us now check the frequency of the generated voltage. So the voltage of this generator is around 440 volts with 60 Hz frequency as shown in the frequency meter. So let us now increase the frequency of this generator and observe the changes in RPM. So as of the moment, the frequency is 62 Hz. So let us predict the RPM using the formula presented here. So since the N in RPM is unknown, so we can rewrite this formula into N equals 60 times the frequency divided by the number of poles. So substituting the values, Substituting the values gives us 930 RPM. So this shows that if the RPM increases, frequency also increases. Or if frequency increases, the RPM also increases. In addition, this simple calculation shows how important engineering mathematics to explain what is happening in practice. Now let us proceed to the parts of an AC generator. So this figure here shows the basic components of an alternator. So to understand the basic operation of this type of generator, let us watch this animation from Ireland Generators published in YouTube.
A generator engine converts diesel fuel to mechanical energy that rotates the crankshaft. As combustion occurs in each cylinder, energy transmits to the engine crankshaft, which generates mechanical power for the alternator. An alternator converts mechanical power into electrical energy in a process called magnetic induction. Magnetic induction occurs when a conductive material such as a copper wire passes through a magnetic field and voltage is produced. If the wire is connected in a complete circuit, the power can be transmitted. Alternators include two primary parts, a stator and a rotor. The stator contains copper coils wound into the alternator's outer casing. The rotor also has wire coils wrapped around an iron core, but unlike the stator, it is attached to the engine crankshaft so it rotates with the engine. When voltage passes through the rotor coils, it creates an electromagnetic field. As the rotor spins, its magnetic field cuts across the stator's conductive wire and generates voltage. Because the magnetic field builds and subsides, voltage fluctuates between positive and negative peaks, which is known as alternating current. The stronger the field, the higher the peaks. Ideally, voltage levels should be consistent so that constant power is provided when under load. To do so, an automatic voltage regulator, or AVR, adjusts the magnetic fields as needed. During heavy power demands, voltage decreases, causing the AVR to increase the magnetic field. Conversely, when power demands are low, the AVR tempers the field.
So if you have some questions or clarifications, please comment below and I will try to answer your questions as soon as I can. So good luck and God bless.